Hello friends, continuing with the topic of electrical capacitance. Today we move on to next part 5 of this topic, the combination of capacitors. The topic is combination of capacitors. What is the need of combination of capacitors? Sometimes a calculated value as per theoretical formula is not available. Therefore, the calculated value is to be formed. It is possible by connecting the capacitors either in series or in parallel combinations or both together. So we take up one by one. First we take up parallel combination of capacitors. When positive plates of the capacitors are connected to one point and negative plates are connected to the other point, the capacitors are said to be connected in parallel as shown in diagram. So in diagram you can see the positive plate of capacitor C1, C2, C3 and Cn are connected to one point and negative plates are connected to the other point. So these capacitors are connected in parallel. Now law of parallel combination of capacitors. When n capacitors with capacities C1, C2, C3, Cn are connected in parallel, then the equivalent capacity of the combination is equal to algebraic sum of individual capacitors of all n capacitors. I repeat, when n capacitors with capacity C1, C2, C3, so on, Cn are connected in parallel, then the equivalent capacity of the combination is equal to algebraic sum of individual capacities of all n capacitors. Now, mathematically, equivalent capacity of the combination can be expressed as C equivalent equal to C1 plus C2 plus C3 plus so on plus Cn. So you look at the diagram here, n capacitors are connected in parallel C1, C2, C3, Cn. So its equivalent capacity will be equal to C1 plus C2 plus C3 plus so on plus Cn. Okay, so this is the law of parallel combination of capacitors. Now let us prove law of parallel combination of capacitors. First we develop physical situation. Let there be n capacitors C1, C2, C3, so on Cn connected in parallel, and the combination is further connected across a source of EMF B dash having potential difference V as shown in diagram. B. Potential difference across each capacitor would be same in this situation because all the capacitors are connected across same points A and B, across which battery B dash is also connected. C. Charge stored in each capacitor. We have to calculate charge stored in each capacitor. Now each capacitor will store charge according to its capacity. Let Q1, Q2, Q3, Qn be the charges stored in capacitors C1, C2, C3, Cn respectively. Then Q1 is equal to C1V, Q2 equal to C2V, Q3 equal to C3V and so on. Qn is equal to Cnv. Adding, we get Q1 plus Q2 plus Q3 plus so on Qn equal to C1 plus C2 plus C3 plus so on Cn into V. D. Total charge stored in the combination, say Q equal to C1 plus C2 plus C3 plus so on Cn into V, where Q is equal to Q1 plus Q2 plus Q3 plus so on Qn. Or from above equation we have Q by V is equal to C1 plus C2 plus C3 plus so on Cn. Or C equivalent is equal to C1 plus C2 plus C3 plus so on Cn, where C equivalent is equal to Q by V, and CEQ in the diagram is equivalent capacity, and Q is total charge stored in this equivalent capacity, and V is potential difference. Now discussion. Discussion part. Equivalent capacity of the parallel combination is higher than the highest in the combination. For example, if we add 1 plus 5, that is equal to 6. 6 is higher than 1 higher than 5. The same way, we have equivalent capacity of the parallel combination is higher than the highest in the combination. Whichever will be the highest, in 1 plus 5, 5 is the highest. So, resultant would be more than 5, and it is equal to 6 in the example as I have explained it to you. The same way, equivalent capacity of the parallel combination is higher than the highest in the combination. Assignment 2.3 continued. Question number 8. Compute the equivalent capacity in the following cases and show that it is higher than the highest in the combination. First example, 100 pf, 100 pf in parallel, equivalent capacity will be 200 pf. So 200 is more than 100. In this example, we have 3 capacitors connected in parallel, 10 microfarad, 20 microfarad and 30 microfarad. So total capacity will be 10 plus 20 plus 30. It will be 60 microfarad. So 60 microfarad is more than 30 microfarad. Now in the third example, here in this example, all the 3 capacitors are connected in parallel. So 5 microfarad plus 10 microfarad plus 30 microfarad. So total capacity would be 15 plus 30, 45 microfarad. 45 microfarad is more than 30 microfarad. So the equivalent capacity is higher than the highest in the combination. Thank you so much for today. Next time we'll take up series combination of capacitors. Till then, goodbye.